Hello everyone. In this lecture video, I will demonstrate how to perform Factorial ANOVA. This is part 3. So before you guys get to this part, I would insist that you look at my part 1 and part 2 videos where I discuss how to deal with outliers, missing values, and test of normality. So here is the example that we are considering. Employees may be interested in determining if the income is different from those with differing degrees and whether the differences are the same for individuals who are not very satisfied or who are very satisfied in their job. So basically we want to see whether the income differs across different levels of degrees and between employees who are very satisfied and who are not very satisfied. So these are the research questions. So we're going to see, is there a difference in income between employees with different degrees? Is there a difference in income between satisfied and unsatisfied employees? Is there a difference in income based on degree held and the level of satisfaction of employees? So this is a factorial ANOVA. So we have two independent variables. One is the degree, which has 5 labels, and then second is the job satisfaction, which has 2 degrees, satisfied and not satisfied. We're going to see different levels of degrees as we continue the analysis, but we have already discussed those in my other earlier 2 videos. So please watch them if you need more ideas on that. So let's go ahead and continue with the analysis. This time we're going to do ANOVA, factorial ANOVA. And in my last video, we discussed how to deal with the normality test. We did not discuss the homogeneity of variance test. So that test is usually conducted while performing ANOVA. So we're going to discuss that thing first, and then we'll interpret the results as we go on. So I'll go back to my data set here. So this is my degree here. That's an independent variable. Job satisfaction 1 or 2 is another independent variable. And I have income 91, which I transformed to income 3 to deal with missing values or to take care of missing values and outliers. Okay, so let's go ahead and do the factorial ANOVA. So we're going to go to analyze general linear models univariate here. I already have the data here, but I'm just going to take it off to start all over. So dependent variable is our income 3 here. Then we have degree, which is ordinal here. Job satisfaction, which is binary. They are both categorical variable here. So model, we want to perform full factorial design with type 3 analysis here. Plots, we want to create a line plot here with the degree on horizontal axis, and we want separate line for each satisfaction level here. So we're going to do that. We're going to add this one, continue here. Post-hoc, you perform post-hoc analysis if you have more than 2 labels or 2 groups in the independent variables. So our degree has 5 groups or 5 5 different labels in it. So we're going to do that, but we're not going to do post-hoc analysis on job satisfaction because it has just 2 categories. So we don't need to do post-hoc on that, or you cannot do that. Only if you have more than 2, you can do the post-hoc analysis. And let's click on Bonferroni adjustment, Bonferroni test here. People also conduct Shefe as well, but they kind of give you very similar results. Here I will do the Bonferroni adjustment. Then save, we don't need to do anything here. Options, I would like to have descriptive statistics already checked here. Estimate of effect size already checked here, and homogeneity test, which is already checked here. Okay, So I'm going to continue here and I'm going to say okay here. Now, so this is a descriptive statistics here. We have already seen that a little bit of that in the split file case which I did earlier. So we know that the how many values are there in each cell. Here we have 15, the lowest. The highest was 196 here. So, and we have also seen that most of the distribution in the cells were not normal, and the group sizes or sample size in each group are very uneven. So, so non-normality distributions coupled with these unequal group sample sizes may lead to the violation of homogeneity of variance test. So that's something to keep in mind. But we don't know yet. We're just gonna go ahead and see that one here. So next thing we're gonna do here is we're gonna look at the Levene's test of equality of variance. And this value is non-significant. So the null hypothesis here is that the variance is equal or same across all 10 different groups. We have 10 different groups here. And the alternate hypothesis is that variance is not equal across all the groups. So we reject the alternate hypothesis and we conclude that since this value is not significant, we pass the test and we can conclude that our sample has equal variances across all 10 different groups. So we can go ahead and do the ANOVA here. So once you are done with the homogeneity of variance test, here the next thing you have to do is look at the line plot. So I'm going to say profile plots here. I'm going to see here. So here you have to basically see, this will help you see if there are any interaction effect between the two factors. Education, which is the RSIS degree and versus job satisfaction. So if you see lines like this which are overlapping and crisscrossing, that kind of indicates that there is some degree of interaction between the two factors. Now, what do you mean by interaction between the two factors? For example, can we see that the people with a graduate degree tend to be more satisfied than the people who have high school degrees? So that means the satisfaction level varies across the degree as well, and together they impact the income. So that's what it means when you evaluate the interaction effect. If there is no interaction between the job satisfaction and the degree, then these two lines should be parallel. But they're crisscrossing and overlapping. That kind of signifies that there is an interaction. But again, we need to do that via statistical testing, because this could be happening just by chance because of the sampling error. So that's the one thing you have to keep in mind. Another thing is that if the interaction effect is significant, then we cannot determine the individual mean effect of degree or job satisfaction on the income. And the reason being that, these two factors are jointly working together affect our dependent variable, which is the income. So we cannot determine their individual impact on the income, and one should execute a lot of caution while doing that in case you have significant interaction effect. So it may happen that your interaction effects are significant and also your mean effects are significant, but you should execute caution while interpreting the main effect when the interaction effects are significant. So we don't know yet that here, but let's go ahead and figure that one out here. So I'm going to go to here, test of between subjects effects here. This kind of gives me statistics to test my interaction effect and mean effect. So you see the interaction here, degree times job satisfaction here, and the p-value is not significant at 0.05 level. So we can conclude that there is no interaction between the factors. That means there is no joint effect of degree and job satisfaction on the income. Even though our line plot here is suggesting that there is an interaction, but a statistical test doesn't say so. Here it's not significant. Okay, uh, so you have to bear or execute caution. So I would say that even the statistical tests are not coming out to be significant. There is some degree of interaction going on here. So again, that this is where you have to bring your domain expertise or experience into the picture while interpreting the results. Okay, but since our interaction effects are not significant, we'll go ahead and see whether the main effect of each individual factor is significant or not. So degree is significant at 0.000 level, and job satisfaction is also significant at 0.007. So they are both less than 0.05. So we can see that income does differ across different levels of degree and across employees who are satisfied and not satisfied. But one should also look at the partial eta square, which tells you how much variation in the income is being extracted by each of these factors. For example, degree is just extracting 12.3% of the variation in the income, while job satisfaction is extracting only 1.1% of the variances in the income. So that's kind of very low. That's also you need to keep in mind while interpreting the results. So even though the mean effects are significant, their effect sizes are kind of very small here. They're extracting very small portion of the variation in the dependent variable, which is income. So that's something you have to keep in mind here. The effect size should be generally around 0.5 or greater than 0.5. That's a very good effect size. If it is about that, then that means these factors are really very significant. So that's something you have to keep in mind here. So once you are done with the between subjects effects, then we move on to post-hoc test here, multiple comparison. And again, for the degree, you cannot do any post-hoc because there are just two categories, satisfied or not satisfied. And since this is significant, we know that the employees' income who are satisfied is gonna be maybe more than not satisfied, and then probably that we can know from here, right? I want, so you can see at the mean. I don't have the means here, but we look at the line plot here. So satisfied people who are very satisfied, which is blue, is always up than the green, more or less. Okay, so that means we can say that the people with the very satisfied level tend to earn more money, hopefully, than the not very satisfied people. Again, you have to do the mean comparison for that category here. Okay, so here it does give us the mean, but if you see here, it also tells you the people who are very satisfied have always higher mean than not very satisfied. So here also, here is they're more or less equal here, but on an average, if you see, people who are very satisfied tend to have more income than the people who are not very satisfied. This is the mean income. So once you are done with that one, we're just going to do the post-hoc test for the degrees, because we have multiple levels. We don't know where the differences are occurring. That's where this multiple comparison is going to help us. Now, wherever you see the star, those are the significant values at 0.000 level. So here you can see that the people who have the graduate degree, their income is different than all other degree types employees. So their income is more than the people who have less than high school, more than the people having high school degree, even the people with the junior college degrees, this graduate degree. So if you see that the mean, the means are always higher for graduate, much higher for compared to the people who have less than high school diploma, and it goes on in proportion. So bachelors, although graduates are earning more than the bachelors, but the difference is not as significant as it used to be between graduate and less than high school certificate holder employees. But graduate, so it's significant across all the other 4 degree holder groups here. So so again, if you see the higher school one, the people with higher school degree, their income is not very significant, because these are not significant compared to the employees who have less than high school certificate or education. Or again, the employees with high school, their income is not very different from the employees who have junior college degree also, because this is not coming significantly also. That's something you have to keep in mind. Also, if you see the bachelor, there is not much difference between the bachelor and the junior college year. So the employees with the bachelor degree, they are not earning any different than the employees who have the junior college or who have attended the junior college degree, because coming to be non-significant. So this is how you would interpret the results here, and that should be it. Thank you very much for listening.